Welcome to this explainer. Today, we're going to break down a massive pivot in the AI landscape. We are talking about OpenAI's return to open-weight models with the highly anticipated release of gpt-oss-20b and gpt-oss-20b. This is a strategic move that honestly, fundamentally reshapes the entire developer ecosystem. We're going to unpack exactly what these models are, how they work under the hood, and what this all means for anyone building with AI right now.
Okay, so let's dive right in by focusing on this number, 6. 6 long years. That is how much time has passed since OpenAI released GPT-2. I mean, for over half a decade, they've been almost strictly an API-only operation, right? They've kept their most powerful models locked tightly behind closed doors. But now, they've made this massive return to the open-source community, dropping these brand new models directly onto Hugging Face.
Here's our roadmap for the explainer. We'll start with OpenAI's return to open source, move into the architecture under the hood, check out the capabilities and training highlights, discuss the Apache 2.0 advantage, and finally, wrap up with developer deployment considerations.
Let's kick off with Section 1. OpenAI returns to open source, delivering their first open-weight models since 2019.
Moving right along to Section 2, Under the Hood, Architecture. Let's deconstruct the GPT-oss framework.
The real magic of what OpenAI has built here is literally in the math. Take a close look at the difference between the total parameters and the active parameters per token. The flagship model has a massive 117 billion parameters, but it only activates 5.1 billion per single token. And the smaller 21 billion parameter model, it activates just 3.6 billion. You are essentially getting the raw brain power of a massive data center model, but with the active computational footprint of a tiny 5 billion parameter model. It's incredibly efficient.
So how exactly are they pulling that off? Well, the underlying technology making this possible is the Mixture of Experts, or MOE architecture. MOE basically decouples the total parameter count from the actual inference cost. Think of it like a giant, super smart switchboard. It takes your prompt and routes it only to the specific expert networks needed to answer that particular query. That explains exactly why you can potentially run these highly capable models so efficiently on much smaller consumer hardware.
Now, these specific design choices, they weren't just thrown together randomly, they were highly deliberate. To get that massive efficiency without losing the model's total knowledge, OpenAI used alternating dense and locally banded sparse attention. They also used grouped multi-query attention, which is huge for saving memory. Plus, they threw in Roche positional embedding, or ROPE, to help with spatial awareness in the context window. Everything here is just hyper-optimized for deployment speed.
All right, on to Section 3, Capabilities and Training Highlights. This is what really makes these models powerful. Check out this number, 128,000. Both of these models natively support a massive 128K token context window right out of the box. This is an absolute game changer for those of you dealing with heavy reasoning tasks, massive code bases, or literally just processing giant stacks of documents. You don't have to weirdly slice up your data anymore. The model can just ingest all that context in one giant gulp.
But honestly, it's not just about reading big walls of text. If you're building function calling pipelines or complex agentic systems, this right here is your biggest signal. Tool use is built right in as a first-class capability. This means GPT-oss isn't just a passive chatbot, it's fundamentally designed to interact with external APIs, execute code, and actually operate as an active agent.
Okay, and this might just be the most mind-blowing detail of the entire release. They didn't just train this from scratch in a vacuum. OpenAI is utilizing a knowledge transfer mechanism here. They used reinforcement learning informed directly by their internal closed frontier models, specifically their OCK3 reasoning model. No joke, they are literally encoding the advanced capabilities of their bleeding-edge private research right into this open-weight release.
Let's jump into Section 4, the Apache 2.0 advantage, looking at licensing and the competitive landscape. Let's talk licensing. Because unlike other supposedly open models out there that hit you with restrictive commercial terms or user caps, this Apache 2.0 license changes everything. It is highly permissive. You can fine-tune it, modify it, redistribute it, and just drop it straight into a commercial product with 0 per-seat royalties. This means GPT-OS is actually fully ready for scalable, real-world production.
This move positions OpenAI squarely against the current open-weight heavyweights. I mean, for the past 2 years, Meta's Llama, Mistral, and Alibaba's Qwen have completely dominated this space. OpenAI is stepping back into the ring by leaning really hard on its superior reasoning task performance, leveraging that frontier-level reinforcement learning we just talked about. Basically, they're betting that their top-tier training quality will win out over the entrenched community support of their competitors.
Finally, Section 5, Developer Deployment Considerations. Let's talk about navigating the hurdles.
If you're an engineer or a product manager watching this, there are 4 critical hurdles you have to systematically clear before committing to GPT-oss in production. Let's break each of these down so you know exactly what you're walking into. First up, hardware. Remember that a 117 billion parameter total means you need significant VRAM just to store the model. Yes, the active compute cost per token is wonderfully low at 5.1 billion. We established that. But your server still has to hold all 117 billion weights in memory at once. The MoA architecture drastically changes your hardware calculus. It's incredibly fast, for sure, but it is still fundamentally very large. Second, and this is absolutely vital, you must run targeted evaluations against your actual workloads. General reasoning leaderboards are great for flashy headlines, but they don't always correlate with specific task performance. Whether you're doing structured data extraction, pure coding, or long document summarization, you have to test GPT-oss on your actual data to see if that O3 knowledge transfer really benefits your specific domain. Number 3, be highly aware of the safety pipeline. OpenAI specifically mentions using worst-case fine-tuning as part of their post-training process. If you're fine-tuning these models for rigid instruction following, pay very close attention to how your tweaks interact with those built-in safety layers. You might run into unexpected refusal behaviors on edge cases, so thorough behavioral testing is an absolute must. And finally, a quick legal heads-up. The Apache 2.0 license is incredible for the code and the weights, but it does not cover the brand name. Always check the model card carefully because per standard open source practice, you cannot freely use the brand name OpenAI or GPT in your commercial applications without restrictions. Remember, you own the engine, not the badge. So as we wrap up this explainer, I want to leave you with this provocative thought. OpenAI has been out of the open weight game for 6 whole years. That means they have no accumulated fine-tuning ecosystem, no massive library of LoRa adapters, and community infrastructure that currently lags far behind Meta's Llama. These models are incredibly powerful, no doubt, but will the developer community rally fast enough to build the integrations needed to make them the new open standard? It is going to be a fascinating few months to watch. Thanks for learning with me today, and keep exploring.